Alright guys, welcome to analyzing graphs of polynomials. So some of this is going to be review, but let's take a look at what the big idea here is. And really to graph polynomial functions right now, we want to make a table of values and find several points and connect them with a smooth curve. It's also very important to know the end behavior of the graph, and that's going to assist you with graphing. So that's really what we're going to be doing today, creating a table of values and plotting our functions, and then there's a few other things that we're going to mix in. So the first function we're going to graph, and the table may look different to you because I ran out of space. So notice how you have x f of x and x f of x here. I'm just continuing on my long table. So I'm going to graph the polynomial function negative x to the fourth plus x cubed plus 3x squared plus 2x. So I made some notes before I even begin with the table of values. This is an even function. It's in standard form. It's a fourth degree. The end behavior is going to be down and down because the parabola, or not the parabola, excuse me, the quartic is opening down because the a value is negative. The leading coefficient is negative. So by definition, the maximum number of turning points this can have is 3. So what you start doing is you pick x values and plug them into the original function and find y. And I've done that here. I'm not necessarily going to review how to do it, but if you look at f of 0, each term has a 0. So 0 to the fourth, 0 cubed, 0 to the second, and 0 to the first. That's all 0. So that's where that comes in. And 1, think about it, negative 1 plus 3 plus 2 gives me 5. So what I've done is I've created all these points, and I've connected them with a smooth curve. Now this function has to open down, okay, and it does have some turning points, and there's the end behavior down, down, so I've connected it with a smooth curve. And that's really the essential part of this lesson, okay. How did I know what this looked like? You notice how I don't make just straight jagged lines. It's got to be a smooth curve, so going like this and there is not what we want to do. We want to make that a nice smooth curve. This is just a pretty general sketch. I've got all my points, so I know these points are on the graph, okay? It's not a perfect graph, but it represents that function. Alright, so in the second example, we're going to determine the consecutive integer values of x between which each real zero of this function is located. Then draw the graph. So what they're trying to figure out, and this is a really key concept here, it's when your y values change sign. If you go from a positive to a negative value or a negative to a positive value, you have to cross the x-axis. So what I've done is created a table, and I just picked negative 2 to 4. Usually, generally, really good from negative 2 to 2, you're okay. Okay, so I put negative 2 to 4, and I plug each of these values into x cubed minus 4x squared plus 3x plus 1. Notice how 0 in this case is 1 because the first three terms are gone, so our y-intercept would be 1. We plug in 1, you get 1 minus 4, negative 3, plus 3 is 0, plus 1 is 1. You plug 2 and we get negative 1. So I've highlighted some things here. Notice we go from negative 7 to positive 1. There's a sign change there. So the consecutive integers that the zeros between are 0 and negative 1 there. And again, when you get to 1 and 2, you go from positive to negative, and we have one more here from negative to positive. I should have made that a bigger arrow. That's also a sign change. So then there's 3 of our zeros between 1 and 2 and 2 and 3. Those zeros are going to happen. I don't know what they are, but when I draw them, we can see between 2 and 3 there was a 0, and between 1 and 2 is 0, and between 0 and negative 1 there was a third 0 there. So there they are, 1, 2, 3, and I've sketched my graph. It's a cubic, so I know at most it can have 2 turning points. Okay, and so there's my graph, and I can find generally where my zeros are by just looking at the sign changes of your y value, your y coordinates. When you change signs, that means you got a 0 in between those integers. Maximum and minimums. We've talked about this. Maximum and minimums occur at turning points. That's the big thing, okay? And they're actually called critical values when you get into calculus in the first derivative. So a relative max occurs, and we look over here. Point A is a relative max because in that area, it's the largest point. Now, see how we have an arrow indicating going up? So this function would continue up, so it may appear it looks like the largest value, but it's not. There's no other point that has a larger y-coordinate in that area, so A is a relative max, and it occurs at a turning point. B would be called a relative minimum because there's no lesser y-coordinate in that specific area. Together, these guys are called extrema. And I'll include some video notes from the TI-84 where you guys can use your calculator to find relative maxes and mins. It's very easy on the 84s. So in this last example here, graph the cubic function x cubed minus 4x squared plus 2x plus 3 and estimate the x coordinates of the max and min. You're estimating. So it's not going to be exact. Well, we'll see if we can get close. Again, I go from -2 to 5. And I'm looking for sign changes, or I'm looking for the largest point in the area. So here's a 0. I know it's a 0 because my y value is a 0. So -1, 0. There it is. There's a 0. And then if you look, I have a relative max here because you have very small value, 0, 3, and then the next consecutive integer back to negative. So there's a sign change here. And so at 3, there becomes a sign change between 0 and 1. So I know that's going to be the relative max in the area because even the point before that was a 0 and the point before that was negative. So that's the relative max in the area, and I keep going, -2, -9, -12, -4, and back to 18. There's a sign change there. There's got to be a 0 in between. And this is the smallest y value in that area between -9, -12, and -4, which is down here. So that's my turning point. That's where my minimum would be. So that's how we can identify x coordinates, and these are estimations. I could find that exact 0 if I wanted to. My relative min in this case is probably close to 3. Okay, I don't know that specifically. Okay, it's just in that general area. If you guys have any questions or comments about analyzing graphs or graphing polynomials, email me below, or type your comments below, or email me at nicholas.bennett@dc.gov.